Google Classroom. Okay. Alright, so this is a slide for fluid static buoyancy. Okay, this is a slide that I did when we were dealing with ODL the first time. I don't have to add anything else. It looks okay at this moment. So ignore the date over here. Alright, so fluid static buoyancy. So the learning outcome is to understand the theory of buoyancy and stability and to solve basic calculation on buoyancy and stability. Okay, so since buoyancy ni should be something that you have heard before, so let me ask somebody here.
Apungan, sir.
Ya?
Daya apungan kan?
Daya apungan, betul. Saya pun nak tanya. Okay, Jenny, are you here? Jenny? Oh, namanya sukar untuk disebut. Jennifer, are you there? Sunyi sepi itu Ada Oh, okay.
Ada.
Okay, daya apung kan? What do you understand about daya apung?
And
How?
upward.
Macam mana?
And upward.
Macam mana dia boleh wujudnya daya apung tu? Because of?
Sebab dia ada dia macam upward force yang exerted by a fluid.
Perform Tahniah Jawapan sebiji macam dalam buku teks. Ni marvelous Terbaik Okay. So tak ada, saya nampak kelas kedua mengantuk kan. Okay. So we are going to continue. So today we are going to go for fluid static buoyancy and learning outcome, as I said just now, to understand the theory of buoyancy, daya apung and stability. This will be two different parts. Hopefully we can do both today. If not, as I said, we will continue in the next class. And then second, to solve basic calculation on buoyancy and stability. Okay, so the meaning of buoyant force is an upward force, resultant upward force, exerts by a fluid on a stationary body immersed in it. So whatever that has been said by Jennifer, the wordings is here. It means it is the same. Okay, so upward force means whenever we have a liquid or a gas, for example, we have an upward force actually from gas and liquid acting upward. Because why is it acting upward? Because the pressure at the bottom should be higher, the pressure at the top will be lower, so pressure should be acting upward. Okay, it's a different thing than gravity. Gravity, daya tarik daya gravity tu is pulling us towards the earth. So it's always going downwards. But for force in terms of buoyant force, it's always going to be upward. However, once again, this thing is relatively unnoticed when we are dealing with air because air has small density as usual. So we don't feel that upward force upward. Okay. However, if you deal with liquid, especially when you go for a swim, for example, you jump into a river or you jump into a pool, you can discover that if you are a good swimmer, you can release yourself from anything and then your body will float nicely. Okay, I'm saying this because I'm not a good swimmer. So if I jump into a pool, usually I'm halfway tenggelam dan tak tahu macam mana nak terapung balik So kalau awak, saya rasa mungkin awak okey, awak berjaya lah Kalau saya dah menggelabah lah So, they said to me, the person who can swim, he said to me, don't do anything, just release yourself from any hesitation and your body will float. Okay? So, the idea from that is, it floats because we have some force acting from the bottom of the pool or the river. If not, you will keep on sinking. Okay? So how do you know or how to calculate this force? Okay, so here we will understand the idea from this picture over here, why there is an upward force from the bottom. Okay, if you can see from here, assuming this is the surface of a liquid, okay, and then we have pressure from the top acting at the object. Okay, so P top is equal to rho F Gx, correct? Because this is just the depth that we have at this moment. Okay, rho F Gx. Okay, the pressure at the bottom will be rho F G x plus H because this is the total depth for okay, the pressure down here. Meaning the pressure at the bottom will be higher, pressure at the top will be lower. This is what we learned from manometer. So from this, what we should know is, because of this idea, pressure will always go from high pressure to low pressure. Okay, so what will happen? The pressure will be going upward. All right, so there will be two different forces acting on an object at this moment. Okay, number one is W, number two is force of buoyancy. Okay, W acts at the centroid of the object. Okay, FB, force of buoyancy, okay, it acts at the centroid of the submerged part of the object. Okay, later on we will see how we get into that. Okay, so the fluid pressure acting on the body at the bottom is higher than the top. So force of buoyancy is equal to the weight. So later on we will see the equation. Okay, so there are three buoyancy conditions. Number one, floating body. Number two, suspended body. Number three, sinking body. So how do you differentiate between these three? Okay, first of all, assuming this is water, so the density should be 1000 kilogram per meter cube. Okay, a condition will become a floating body when the density of fluid is higher than the density of object. So if the object has a density, for example, 700 kilogram per meter cube, we will assume that the body will keep on floating. Okay, because the density is much lower than density fluid. If somehow you have a body on an object which has the same density as the fluid, for example, water is 1000, the object over here is also 1000. So what will happen? You will have a suspended body. Suspended body means it does not float and it does not sink, it is staying in between. Okay. Number three will be sinking body, all right, where the density of object should be higher than density of fluid. For example, 8000 kg per meter cube. What will happen over here? The body will keep on sinking. So these are the three types of body that may happen in a system. Okay, so to make a floating body into a suspended body, since it is floating, it requires a force to push it downward until it becomes suspended. To make a sinking body a suspended body, what you have to do, you need an external force to pull the box upward so that it goes in between the surface and also the floor. All right, any question on this? Daniel, are you here? Daniel? Are you here? No. Alniza, are you here?
Yes, sir.
Okay. Any problem?
Okay.
Okay.
Sir, which Daniel, sir?
Oh, ada dua Daniel
Ah.
Daniel Chung. Is it Chung? Daniel Chung. And ada Daniel, apa nama?
Daniel Zikri.
Daniel Zikri. Okay. Okay, next time saya panggil ada kat belakang itu Alright. So, the equation for this particular study, we have a simple equation over here based on Archimedes principle. Okay, pernah dengar kan Archimedes? Pernah Oh, sedap pernah. Tanya, cerita Archimedes cerita pasal apa? Arif Fahmi. Pernah dengar Archimedes?
Nah,
cerita dia pasal apa Archimedes ni?
pasal yang tu.
Yang tu.
Yang dia masuk dalam tak mandi tu.
Masuk dalam tak mandi. Oh, betul. Perform petang ni. This is a good class
Baiklah.
Semua tahu
Thank you.
terbaik
Masa dia masuk dalam tak mandi tu, dia tengok ada air sikit keluar.
Okay.
Eureka.
Eureka.
Eureka tu kalau sebut banyak-banyak tu macam tengok The Big Bang Theory So, okay, Archimedes principle betul. Ideanya ialah the buoyant force acting on the body immersed in a fluid is equal to the weight of the fluid displaced by the body, and it acts upward through the centroid of the displaced volume. Okay, don't worry, the wordings over here can be represented in a picture. Okay, so idea Archimedes ni saya rasa you get the idea from cerita pasal a crown and learning how what is the volume of a crown. So tak tahu macam mana nak tahu apakah volume for a crown that looks like this. Zaman dulu tak ada komputer untuk calculate and it's hard to calculate a design like this. So what is done over there is the crown is put inside here, water yang melimpah tu akan dikumpulkan, then diorang check what is the volume of that water. So that will be the volume of the crown. Okay, so as that said, it means bila kita masukkan body ke dalam, kita replace liquid dalam tu. Kalau tank ni full, air akan melimpah keluar. Meaning, the amount of volume coming out tu will be the volume of the system. That will be based on the Archimedes principle. So, apakah yang dimaksudkan? What is the meaning of this wording over here is, okay, if I have, today is not a good day of me drawing things. Okay, assume lah this is a very nicely done box. Okay, for example like this, a block like this. Okay, alright, so whenever we have to learn about the idea of buoyancy, as I said last time, we have to learn the idea of whether it is sinking, it is suspended, or it is floating. Okay, alright, the equation that we have for buoyancy is based on this equation. FB is equal to W. FB is force of buoyancy and W is weight of object. So force of buoyancy okay, W is the weight of object. Alright, force of buoyancy can be calculated by using this equation. Density of fluid, G times V displacement. Okay, the weight can be calculated this way. Rho object, G, V object. So, force of buoyancy is for the liquid. Okay, W is for the object. Alright. Okay, so now, if we open up the calculation for V displacement, it is equal to A, area of surface, times H displacement. For object, it will be area of surface times H object. Okay, assuming we have a block that is the same area of surface, which is this one at the top. So this is the area of surface. This is A. Okay, the length from here to here, let me change colors for this one. The length from here to here is called the width. Okay, here to here is called the length. Okay, here to here is called the height. Okay, alright, so if the surface area over here is a shape of like this, okay, we can know that the surface area is equal to width times length. Okay, so the difference that we get for FB and W is based on the height. So how do we get the calculation? Weight will act at the centroid of the body of the object. So I said just now, weight is acting at the centroid of the body of the object. Okay, so if I have a body like this, if I want to find the centroid, it should be somewhere here. Okay, so the distance from here to here, okay, is considered to be the height of the object. Okay, the total distance from here to here, height of the object, and the weight will be acting downward from here. Okay, weight will be acquired from the centroid. Ini centroid, eh? Alright, so to find out what is the height of the object, it is from top to bottom, like this. It is called as H object. So this H object will be used in this calculation. Alright, second one will be on H displacement. So how do we find H displacement? Okay, so this part of the water is submerged underwater, correct?
Correct.
Alright, so where do I find the H displacement? Okay, H displacement is the distance that we have from the submerged part of the surface. Okay, so from bottom of the body to the submerged part, which is, this is H displacement. Okay, we only calculate the height from the bottom of the plate or the body up until the surface of the liquid. That will be HD, H displacement. And force of buoyancy is acting at the centroid of the body submerged in the plane, which is here. This is where you have your force of buoyancy. Okay, so this one is the centroid for submerged plate, submerged body. Okay, so this is the idea of this equation, which is FB equals to W. So to help you understand this equation, so first we do a question. Example 1. A block is floating in water as shown in figure 1, like this. Determine the height of the block submerged in water if the height of the block extended out of the surface is 0.2 meter. So this is 0.2 and this is H, unknown. Okay. The density of the block is 780 kg per meter cube. Okay. While the density of water over here is 1000 kg per meter cube. So determine the height of the block submerged in water. So the height of the block submerged, H over here, is HD. Okay. So the height of the object for the study will be from top to bottom, which is 0.2 plus HD. Okay, will be H object. Alright, are you clear with this?
Clear.
Okay,
Yes.
clear. Alright, the length of the block, length is going to the back like this. So the length is equal to 1 meter. And then the width, which is going to be this one, is 0.5 meter. Alright, so if you want to find out what is the area, area is width times length equals to 0.5 times 1 meter. So it is equal to 0.5 meter square. Alright, okay. So to find out the calculation, we just use the equation that we learned just now, which is FB equals to W. If we open up the equation, FB is rho fluid, G V displacement, W is rho object, G V object. If we open up the VD, it is equal to area times HD, VO is equal to area times HO. If you discover from the picture, this is a block which has the same area at the top here and also at the bottom, okay? Because it should look like this. Okay, the area should be the same. So we can assume area is the same at the top and at the bottom. So we can cancel out the area for both sides. G, 9.81 meter per second square, as long as we are in the same environment. Okay, they have the same 9.81 meter per second. Right? Rho F or rho object will be different. HD and HO will be different. Why? Because this is floating. So HD is HD. HO is equal to, just now we already get the HO from this picture. which is 0.2 plus HD. Alright, so if we rearrange, we can find out what is HD. Okay, so HD is equal to rho object times H object divided by rho fluid. So this is rho object 780. This is rho fluid 1000. 0.2 plus HD is H object. Okay, so we get this to be equal to 0.7091 meter. Clear? Alani, are you there? Alani Najah?
Yes, sir.
Okay, tak ada masalah
Okay.
Okay, alright. So that's a simple question that you can just use this equation here. Alright. I'm giving you the second example. This one is a bit different. Okay. 2 cubic block, oak and steel with the same dimension, 0.5 times 0.5 times 0.5. It means we are having a cubic block, okay, where you have, this is 0.5, this is 0.5, this is 0.5, right? Determine the amount of external force required to hold each block suspended in the fluid and the direction of each external force. This one is a bit different. Okay, number one, drop into an oil tank here, meaning the liquid that we are dealing with is oil, which is 850 times 850 kilogram per meter cube. So this is the fluid, all right? This is the surface, and this is the floor, for example. Okay, so let me ask Abdul Hayy, are you there?
Yes, sir.
Okay, oak block, 700 kilogram per meter cube. If you leave it that way, will it be sinking or floating? Oak block, the chocolate color, the brown color box. Oak block, if you leave it this way, will it be sinking or will it be floating?
I think you is still sinking.
Sinking,
No, apa? Wait.
Wait, okay, I'm waiting.
Floating.
Oh, okay, why?
Because the density is more or less than other other block.
Correct. So, row of oak is lower than row of oil. Okay, so it should be floating. Steel block, Abdul Rashid, is it floating or sinking?
Sinking, sir.
Because?
It has higher density than oil.
Yeah, correct. So flow of steel will be higher than the density of row of oil. Okay, so row of steel higher than row of oil. This should be sinking. Okay, for this question, the question asks us, what will happen if we want to, what is the amount of force required if you want to make these two blocks suspended, meaning it is not floating, it is not sinking. Okay, because oak block, if you leave it that way, it will be floating. It requires us to use an external force acting downward so that it will push the block to the suspended position. Steel block, it is sinking. To make sure it goes up to the suspended condition, we have to pull it upward for FE. So different condition requires different force acting at different direction. Okay, so before this, whenever we learn about buoyancy, we only have two force, which is weight and also force of buoyancy. Why? We do not want this to be suspended. So if it's floating, it's floating. We don't have any external force in the study. Okay. However, right now we are dealing with external force. When we have external force, we have three different forces, Fe, W, and Fb. So we need to do summation of F in the y direction equals to 0. Going up is positive. Okay, so let us see how we do the calculation here. All right, So the calculation is pre-calculated for you guys. Okay, so oak block. For example, this is the oak block. Okay, as I said just now, the external force is acting downward because we want to push it to the suspended condition. So going downward is negative minus W plus FB equals to 0. Okay, so FE equals to negative W plus FB. So what we want to find out is the external force. Right. So W is equal to rho object, rho oak over here, times G times volume of oak, okay, plus force of buoyancy will be rho oil times G times volume of displacement. However, if we are in a suspended condition, both HD and HO should be equal to each other. Why? Because the body will be fully submerged, so the height of submerged body will be the same as HO. In this condition, volume of oak and volume of displacement should be the same. Okay, once again, I'm telling you, if you have a suspended body, the whole body is submerged in water, it means that HD over here should be the same as HO, because the total body of the object or total volume of the object is fully submerged. So because of that, the volume should be the same. All right, so the equation, we can factorize it. G will be the same for both sides. VD will be the same, okay? So multiply by negative rho oak plus rho oil. And you get the idea here. The external force is 183.94 Newton downward. All right. How about steel block? Okay, steel block, the force, external force is moving upward because we want to pull it up. Okay. So we do the same. FE is positive minus W plus FB equals to 0. So FE is equal to W minus FB. This is different from this one. Okay. All right. So what we will have here is rho S, G, Bs, rho steel, G, B steel for W. FB is also the same. As usual, it is fully submerged. So these two VD and BS will be the same. So we factorize it. And the density S is minusing the density of oil. So you get the answer to be Fe 8829 Newton in the direction of upward. Okay. So if you can see, since the difference between oil and also steel is really big, okay, in terms of density, so the amount of external force required is also really high compared to the oak block. This one, we only have to use 183.94 Newton to push it to the suspended condition. Here, we have to use 8,000 Newton to pull it up from sinking to a suspended body. Okay. Any question? Alexter, are you here?
Yes, sir.
Ada soalan tak based on this?
Kalau setakat ni tak ada sih.
Setakat ni tak ada Okay. So now